Hello everybody, we're going to do the centripetal force problem on number 10 on the worksheet here. That's AP problem, sort of a nasty one. And you got a 1,200 kilogram car, that's its mass. It's banked on this 12-degree off-ramp of an expressway here. This gets a little tricky because this car is actually coming out of your computer screen. This little star right here is the center of the clover as the car comes off the expressway, and the car would actually be going into the board over here. Okay, so hopefully you can sort of see what I'm doing. It's coming out of the board at your nose. This would be the center. So the radius between the car and the center over here, that the off-ramp, would be 70 meters. That's going to be our radius right there. So I need to delete all this so you can sort of figure out what's going on. So I'm also going to delete the car so I can draw some vectors. And once again, this is the off-ramp that's coming down. And if my dot is now going to represent the car, the road is going to push that car with a normal force going, once again, a right angle to the road. It's the normal force right here. So I call that normal force. And the road has to push two different directions. It has to push straight up against gravity this way. Okay? And then it has to push towards the center of that, or in the direction of the radius here, towards the center of the circle that the car is going around. And since that red arrow is pushing towards the center, we can call this the centripetal force. And the green arrow, I'm going to go ahead and call it the force of gravity, even though it's acting straight up. It's the vector that's acting against gravity due to the road. So it's going to be equal to gravity. Once again, the normal force is your blue force. So if you look at the problem here, it says that the car is traveling 90 kilometers per hour. Well, that's the first thing we cannot use. So we've got to change that 90 kilometers per hour into meters per second. And so once again, there is, in this case, 1,000 meters in a kilometer. So I'm going to put 1,000 meters on top, 1 kilometer on the bottom. There's in 1 hour, there's 3,600 seconds. And so if you multiply that out, you get a speed of the car going somewhere in the general vicinity of 25 meters per second. So that's going to be my velocity, equals V. Okay. And it wants to know two different things. It says, what is the friction force of the road, and also what's the coefficient required to hold up the car? Well, the only thing actually holding the car on the road is centripetal force. So all the forces that make the car stay on the road is going to be considered a centripetal force because the car is going in a circle. And when you look at the two forces that make the car go in that circle, one is going to be the force of the road in the x direction. I'm going to put a little x down here. And then the other one is going to be the force of friction. I'm just going to use blue for this. So force of friction. And since all this is in the x direction, centripetal force, the road, and the friction are all in the x direction, I'm going to put a little x there too. Well, I don't know any of these, so we're going to have to substitute in some formulas to help us out. Well, the formula for centripetal force is m times v squared over r. Now, the road gets a little bit tricky because the road's pushing straight up due to gravity. So that green would be m times g, because the force of gravity is m times g. But that is in the y direction. We want to know what the road is pushing in the x direction. So let's take a look at this. If I know that the green side here is the adjacent side, let me show you how I got that, because this gets a little tricky too. I'm going to extend this green line down, because this green line would be the gravity line going straight down. You can see I just made a little right triangle down here. And I'm going to extend this blue line out down here too, like so. So you can sort of see these things. And if that is a 12-degree angle down here, that means that this one must be a 78-degree angle. If that's a 78-degree angle, since this black and blue line make a 90, that means that this one must be 12, because those have to add up to 90. And for opposite interior angles, that means that this one must be 12. Okay. So let's take a gander here. This green line going straight up like this, that must be the adjacent side. The red side, which we're looking for, must be the opposite side. So we're going to use the tangent to find out how much the road is pushing in the x direction. Well, I'm looking again for the opposite side. So let's look at this green triangle up here. If I'm trying to find the opposite side, it's tangent times adjacent. So for the road in the x direction, I'm going to put in the tangent of 12 degrees times the adjacent side. Well, the adjacent side is this FG over here. So I'm going to put in mg, the weight the road has to push against. And then all of that has to equal the friction force in the x direction. So let's figure out what the friction force is in the x direction by plugging in some numbers. Well, the mass of the car ends up being 1,200. We got a velocity of 25 meters per second. Don't forget you got to square that slap in. That's 1,200 kilograms. The radius was 70 meters. That equals the tangent of 12 times the mass of 1,200 times gravity of 9.8. And that's plus the friction force. Let me go ahead and put that in blue. I don't know why I wrote it all in red, but it's the friction force in the x direction. And so when I solve for the friction force in the x direction, that ends up giving me 8,214. So the friction force in the x direction is 8,214. It's 0.6, something like that, newtons. Well, you don't want the friction force in the x direction. You want actually what the friction force going up the road is. So let's take again at how we're going to do that. Okay, so I drew another triangle down here so you could sort of see, just looking at friction. If your car is sitting right here, so I'm going to draw your little car again right there. There's your car, there's the headlights, here's the little wheels of the car right there, okay? And your car, once again, is coming out of the board, okay? And friction is actually making it go downhill. Now, let me show you why. If you're coming around an off-ramp, if there was no friction, your car would just sort of slide right up the road like that and fall off the off-ramp, okay? So that means friction must act down the ramp like so. Okay? So friction is going to push this way. That's going to be my friction force that I'm looking for. Well, friction is actually pushing diagonally down. That means it has to push in the x direction this much. So that was my 8,214.6. And then it must push in the y direction this much. Okay? So it's pushing the car down the ramp to try to keep it from flying up off the ramp. Well, if I now want to find the hypotenuse, which is that red F there, and I know the adjacent side, don't forget that this is going to be a 12-degree angle again. Then, if I'm looking to find the hypotenuse, I want you to look at this blue triangle over here. You want to find the hypotenuse, this one right here. Cover up that H. And so that means it's adjacent divided by the cosine of the angle. So what I'm going to do here is I'm going to take the adjacent side, which is, see, this is the hypotenuse, the force of friction. It's going to be equal to the adjacent side over the cosine. So the adjacent side was 8,214.6 divided by the cosine of 12. And so the friction force ends up being 8,398 newtons. Now we got to find the, coefficient of friction. Remember, the coefficient of friction from 2 chapters ago was the force of friction over the normal force. This gets a little tricky. Well, the force of friction we're going to put down, that's what we just found, of 8,398 newtons. Well, the normal force is that blue line up here. So let's look at this blue line up here. Well, if you know the green line is mass times gravity, and that's your adjacent side, and you want to find the hypotenuse, once again, we're going to take adjacent over cosine. So this time, I'm going to write this down. The normal force is adjacent divided by cosine of the angle. And I got that from right up here. I took this adjacent over cosine of the blue triangle here. Well, let's look what this is. I'm going to once again put my 8,398, which was my force of friction, divided by the adjacent side. Well, that's mg. So m was 1,200. G was 9.8. And then I divide that by the cosine of 12. When you get all that together, you end up getting somewhere around 0.698. That's the coefficient of friction, which is quite rough. And I'm going to show you some pictures of the expressway ramps and how they use different materials to make that a little bit more sticky. So when your car goes around the curve, it actually holds it on there. Have a great day, everybody. Thanks. Bye.